Hello everyone. This video is about memory management in Java, basically trying to understand the concepts of heap and stack and how they are important in Java memory management. Um, there are two major concepts, heap and stack. So let me first start with the stack memory. What is a stack memory? The stack in Java is a section of memory which contains methods, local variables, and reference variables. Stack memory is always referenced in last in, first out order. So anything which starts um, last, so that must be out first. Now, local variable are created in the task stack always, and now I'm trying to explain about the heap memory. So, heap is a section of memory which contains objects and may also contain reference variables. Instance variables are created in the heap. So, always the stack memory. It points to the methods, its local variables, and reference variables, whereas heap memory always deals with or stores the objects, any objects or any number of objects that gets created during the program execution. Uh, the Java virtual machine, which is responsible for the program execution, so it has divided the memory into different sections. So the main sections are heap, stack, code, and static. So here you see there are different concepts: code, static memory, stack. I just told you about this. Automatic memory, heap, free stored, and method area. So I'm going to explain or use all these concepts through an example. So let me first explain you about the code. So code always it's nothing but your statements or the byte code in your program. And then the stack is a section of memory which contains methods, local variables, reference variables. Then we have heap, which I already explained. It contains the objects. It may also sometimes contain the reference variables. And static section, static memory always contains the static data or methods. Now I'm going to take you to one example here. So here, if you see this example, so in the left hand side, we have our code. Mm, so there is a class memory region X. In it, there is one static member field, my static field, one method, void type method, my method, one my local variable, which will be stored in the stack. How I'll take you through the steps here. And the my local is going to be assigned with 999 and then just trying to print it out. So this is my method. Now let's see our main method. In the main method we have one my int variable, um, then one integer type generic variable my integer assigned with null, then another, then our my int is supposed to be assigned with 555, then again another integer object is to be created that with the value 222, then trying to print the value and some extra statements following it. So let me first start the code. Okay, before this I need to tell you one thing. In the right hand side, there are four sections in the memory. So the code memory always contains your byte code. So these are nothing but your the statements inside the program. Individual program statements or instructions are supposed to be stored in the code memory part of the memory. And one by one, each instruction will do its work or complete its task. Then we have static memory. So static part actually contains any local variable, any methods or reference variables. Then we have stack. The stack section will contain its related data, and this is our heap section. Let's start the code. Okay, so here you can see first, in the code memory region, it has stored with starting the program execution. by executing one by one all the instructions in it, it is going to store all the program instructions in the section of code memory. Now the my static field is one field of our static memory section. So the my static field, which is the local variable of memory region class, assigned to 33, that 33 is now going to be stored into my static field with an address 3000. So here this is one local variable of our class. Now I'm going to go next in the step. So with the execution of the main method, the different locations or the fields are allocated in the stack memory. So first the my int, then the my integer. My int is again here assigned with 555. So 555 is stored in 3200, and my integer assigned with um, null, which is stored in 3201. So when main function is called, the variables my int and my integer are added in the stack, in the appropriate locations in the stack. I'm gonna go next. Here, a new object, okay, one object. Now in the a new object is allocated to the memory on the heap, which is an integer object, and that's with the value of 222 again. So what happens now? So with this statement, with the new operator, you are trying to create one object. Okay, this is not a simple variable. That object is supposed to be created. So if there is any object gets created in the program execution in the Java program, then it never goes to the stack. It goes to the heap section, and that is our integer object. So new allocates the memory on the heap for the integer object and returns its address, that is 9400, to our my integer, because 222 is directly referenced by this address 9400. Okay, so the value of my integer is now just a address, nothing but not the value itself, 222. Now let's go next. Now the my integer is supposed to be assigned to null. Okay, my integer is assigned to null, so that is why now it has null here in the my integer section. And then when calling the my method again, it grows the stack along with assigning the next member variables as per need, and then pushing the method's local variables in the stack. So my local here takes the 999 because the call of the my method go takes the control here, and here my local is assigned with 999. So that is one space or one field has been allocated for my local with a value of 999. So then the statement we have my local is a print statement. So after this statement is executed, there is no need of using my local. So here it's the time to delete or make the space empty for that assigned my local variable. And those local variable are now removed from the stack when the method is returned. Okay, method is called, it's executed. Now it comes back here. Now after everything is done, okay, so now the object, now you don't need the object also which has been created for the 222 my integer one. So everything is done now. You are done with execution. So now all the memory will be empty, or all the spaces will be deallocated which was allocated before. And this deallocation of space also leads to another one concept called garbage collection. How I will explain you in the next video. So this is the basic concept of stack and heap. Stack usually have the method section, local variables, and reference variables, whereas the heap always keep tracks or stores the objects.